Hi, I'm Justin Kirk, and in this video I'm going to show you the entire process for coding an enemy in Unity. So unlike the other tutorials you can find online, they're mostly using just like cylinders and stuff, right? I'm going to actually show you with like a real game model. This is going to be probably a really long video, but it's going to be worth it to stay to the end. I'm going to show you a bunch of things that you probably won't know. Even if you're like a veteran Unity developer, you're probably not going to know a bunch of this stuff. Basically what I have is I have this enemy, and these are just gizmos showing on the ground like where he's going and like the path that he's taking. These lines on the ground, the blue line, this is the maximum height or z-axis of the room. So like the max is here, and then the min is here, and then this is the x-axis for the red line. All these white lines, this is what I'm using to divide the room, so I can put objects in the room so that they're in uniform like positions. The green line in front of him is his line of sight, so if you walk into his line of sight, it will trigger him to start chasing you. So I'll show you that. Hang on. So I'm just gonna walk in front of him. Yeah, so you can see he starts chasing you, and then he has this cool like gun animation where he shoots like these balls, and if you get hit by it, it does damage to you, obviously. He also has another attack. Hopefully he'll do it. I'm not gonna waste too long waiting for him to do it, but come on, do the other attack. Shit. There it is. Okay, it didn't actually show it because I got hit by the hammer. There it is. Okay, so like I said, this is going to be a really long video, and I'm going to try not to cut as much of it as I can so you can see the entire process. So I'm just going to go ahead and delete the cow that I already made, and I'm going to drag in a new cow from the prefab, or sorry, not the prefab, the imported model. Somewhere in here I have a cow. I think it's this one. Oh, and this one only has the gun attack, but that's fine. I'll only add the one attack, and then you could just add any attack you want because your enemy probably won't have the same attacks, so you'll have to do this on your own enemy. But anyway, so to start, all you have to do is drag your model into the scene. Now, you have to make your own model, so if you don't know how to make a model, then this isn't going to be useful. I mean, you could do this with a cylinder or any game object you want. A lot of the code is just completely, like, you could just reuse it for any type of enemy or any type of thing. Things like having the character walk around and find a spot to walk to, like a random spot to walk to, you could just reuse that. It doesn't even matter what type of character or model you have. So after you've dragged the enemy into the scene, the first thing you want to do is just unpack him. So right click, prefab, unpack. And then we want to drag his avatar onto the avatar slot. Oh no, he's already got the avatar, sorry. So I've created a new folder at the bottom called tutorial 4. And we're going to go through everything for making the enemy. So this, like I said, it's going to be really long. So first off, he's too small, so we're just going to make him bigger. And we just need to right click at the bottom, create an animator controller. And we'll just call this tutorial enemy controller. And then under the enemy, you can see that there's a slot for the controller. So you can just drag this into that slot. In the so if you double click on the tutorial enemy controller, you should get a screen that looks like this. So if you right click somewhere in here, you can create a state, just make it empty. And then in this state, this is his default state. So we want this to be him walking. So this is what he will do by default when he's not doing an attack or anything else. So we just need to go to our model again, and we're just going to take all of these animations and we're just going to copy them into our folder that we're using for this. And because there's two animations for mine, I'm going to use a blend tree to blend the animations together. So one is the hammer moving, and the other one is him walking. So let's rename this to walking. And if you right click, you can create a new blend tree in state is what you need to do. And then double click on this. And then if you click on this, you can add motions. So you can have multiple animations playing at the same time. You don't want to automate these because you want them happening at the same time. So change the threshold for both of them to 1. And then for me, I have 2. So you probably only have 1 animation for yours. So you'll just drag your walk animation into the main thing. But if you have multiple animations that you want to play at the same time, you can use a blend tree like this. So then back in the base layer, you don't have to do anything for this. Like it should just be, so if you run this right now, he should just be walking automatically. I'll run it, hang on. Okay, and my animation is fucked up because he has frames inside of both of these that are for the wrong things. So I'm just going to fix it really quickly. Hang on. So the first thing we want this to be looping. And if you double click on hammer walk, it's only supposed to be his hammer moving in this, I think. Wait, no, I think hammer walk I have them backwards. So this is just the character bones. So this has... Yeah, so this is the hammer one. So we just need to take all of these other things that are inside of this and just delete them. So hang on, let me just get rid of all this shit. You probably won't have to do this. This is just because I exported it wrong from Blender. So then this one has the actual movements. So I'm just going to delete the hammer. So now if I play this, it should be walking properly. Cool. Okay, and this will just repeat over and over again, and the speed will probably need to be changed or whatever. But so this is his default walking. So he's obviously not moving or doing anything like that, but it's just the animation of him walking. So whatever animation you attach as your first animation, he'll just be doing this by default while he's not attacking. And this is good enough for what we're doing for right now. So now we need to make a script. So let's stop this. And we're just going to right click in this folder, create a script. And you can just call it, I'm just going to call it tutorial enemy script. But you can call yours whatever you want to, it doesn't matter. And then on your cow enemy, you can go ahead and attach this script. Actually, just drag it onto. Okay, so after you've created the script, go ahead and open it. We're just going to delete everything to start with. And the first thing we're going to add is on gizmos selected. So what this does is when you click on your enemy, you'll actually see the gizmos for him, because we're going to add a bunch of gizmos so he actually can see. It's like imaginary lines that get drawn that you can see. Like, for example, these white lines that are splitting up the room, they're gizmos. When you actually run the game, they don't show, like, you can, in the actual game, there won't actually be them. They're just showing for, like, a references. So that's the first thing we want to do, is we want to actually have this drawing. So I'm just going to copy the gizmos from my real script that I already have. I'll just copy one of them so that you can kind of see how it's working. So this one is a green. I changed the color of the gizmos to green. The direction is the object, the forward of the object. So in front of the object times 100, and then the z-axis in front of him times 100. Yeah, so this basically will draw a green line 100 units in front of the cow, the thing that we're attached to. So if we save this and we go back here, you should see that there's like a line in front of the cow now. And we need to put this cow enemy into a container. So the forward of the object of my enemy is wrong. So the forward right now is showing behind him. So if you export your character incorrectly and this line is not facing in front of the character, you just have to put this game object inside of another game object and then rotate this 180. So what we'll do is we'll right click and we'll create an empty, and we'll call this cow enemy container, and then we'll drag the cow inside of this container, and then this enemy can be rotated 180. And then we need to take this script and remove it from here. And we're going to remove the animator as well. And then on the front of this, like, sorry, at the root of this, we'll go ahead and add the animator back. And then we need to go and get the avatar. So inside of your imported model, you can just drag the avatar on top of this. If you don't see an avatar, you just have to click on the on the enemy or the object that you have and go to the rig. And then under avatar definition, you just have to choose create from this model and press apply. I've already done this for this, that's why my avatar is already there. But if you don't have one there, then you have to do that for it to show. So let's just make sure I've dragged this in here. Okay, and then back in our tutorial, we'll drag the controller back in here. And then we'll just add that same script, so tutorial enemy script. So if we save this, okay, so now the new problem is that this is not in the center, so we just need to reset this and then change this to 180 again. And then, oh my god, I should have just reset the position. Hang on. Oh shit, we moved him again, damn it. We need to move this guy. There we go. Okay, so if you've done this correctly, you should see a green line directly in front of your character. this is really important. So if your normal is wrong, like the direction that he's facing is not right, and you go to add a bunch of code and you haven't done this already, you're not going to know whether the front of him is facing the right direction, and your code could make your character walk in the wrong direction, and you'll do a bunch of testing. You'll probably be able to figure it out eventually, but it's way better if you just create a gizmo and you can actually see what's in front of him. So you can just copy this code. This should work for any. So this will just put it 100 units in front of him. If you want it to be more than that or less than that, you can just increase the number or decrease the number. The y-axis I set to 10 because I don't want it to be directly on the ground. So if you just use the transform position to draw the ray instead of separating the axes and putting 10 here, then the position of it will be directly on the ground. So like if you look at the cow enemy container and we zoom in on this, you can see that this ray is not directly on the ground, it's above the ground. If it's on the directly on the ground, it will kind of blend in with the ground and it makes it really hard to see. So that's how he can. So we're going to use this exact code to detect whether somebody's in front of him, or like if your character runs in front of him, we're going to use this same code to detect whether there's something in front of him later. So that's the first gizmo we want to draw. So the second thing that we want to draw is the dimensions of the room. So when he gets a point inside of the room that he's going to walk to, it's nice to know if the dimensions are like if that point is always going to be inside of the room, and we want to be able to change that depending on what plane he's standing on, because we're not just going to have this cow go in just this room or this enemy go just in this room. He could be in any room, so we could put him in any room and he'll just automatically know where the boundaries of the room are, so he doesn't go walking off in outer space. So we need to get the max size of the room. So to do this, we could input the plane, or we could get the plane he's standing on by using a raycast, but we're just going to get it this way for now. So you could do serialized field and then plane enemy is on. Okay, so if we save this like this with serialized field, you should be able to see it in the inspector. Oh, it's a game object, it's not a plane. A plane is, okay, so there's two types of plane. This plane is like an imaginary invisible one that you can use for like raycasts and stuff like that. The plane you're standing on is a game object. Okay, cool. And here, we'll just take the plane that he's standing on and we'll put it into this slot here. So then to get the max x, so we'll do float max x is plane enemy is on, and it's actually times 10, so, and then divided by 2. So the plane we're standing on, planes are 10 units in size. So instead of it being, like, let me click on the plane, hang on. So instead of it being 40, it's actually 400 in size. It just says 40. So we're going to take the local scale of X and Z. And if, let's say this is 400 in size, well, 200 is where the wall would be on the X-axis. So let me just, you can see the coordinates in the top left here, or the top right here. So the max X, or sorry, the max X on this side is 200X, providing your plane is at 0, 0. If your plane is not at 0, 0, you have to add the transform, like how far away from the origin it is. So you'd have to add the X value of the position to it. But my plane is at 0, 0, so I don't have to do that. So this will be 200 units, and then this will be negative 200 units. So the min X is just negative the max X. And so this is the same thing for the Z-axis. I'll just copy paste this. Okay, so now we have the max X, the min X, the max Z, and the min Z. We don't need Y, obviously, because that's like vertically up and down, so we're not going to be moving the character up and down. Our character doesn't jump or do anything like that. So now we're just going to copy this, and we're just going to change some things on it. So the color for X should just be red, because that's what it is in the actual game. So red is X, so we'll just change the color to color.red. And then the direction, so we're going to have a from is going to be max X. And no, it can't be max X. So max X is a float, so we need a new vector 3. And it's going to be max X 5 to have it like off the ground. We don't want anything directly touching the ground because you can't see it. It will like kind of glitch between the ground. And then we'll just put this directly in the middle of the room. So we could just put 0 for the Z, because again, we have this centered, so that's perfect. And then we just need a 2. So like this. And we can do min X. Oh shit. And then we can do gizmos dot draw line. Oh, perfect, it did it for us. So the Z-axis is the same thing. So we'll do that here too, and we'll just make it blue because blue is the Z-axis. And then it will just be Z instead of X. Oh, I didn't do capital. Cool. So if we save this and we go back to our game, we should have a line, like a cross line here. Oh, only when you select your cow though, or your enemy though, because we have it on selected. You could, did I save it? What happened? It didn't draw a line. Oh, these are backwards. Okay, I see. So this should be 0. Just make this min Z, max Z. Oh, this should be local position. That's why. Also, it should be scale. It shouldn't be position. Oh my god. Okay, so I put position instead of scale. This is the reason that it's not working. So just change this to local scale instead of position. The position is not right, obviously. I just let it autocomplete. I wasn't paying attention, so. Okay, so there you go. So now we have a line between the top and the bottom. So now we want to add some overlap space because we don't want him trying to walk into the wall. So this red line, like if we were to hide the door and all this stuff over here, we would probably see the line goes directly to this edge, but we don't want that. We want it to actually stop sooner than that because we don't want him walking into the wall. So what we can do is we will minus 30 from the maximum and then add 30 to the minimum for both. Now, I'm using a really big scale for my game. So if your game is like a smaller scale, you can see, like with the gizmos, you can see the size, like how big it is or whatever. So you just need to make this the appropriate number for your game. Mine might be completely different than yours, so this looks pretty okay. It looks like the Z-axis is wrong, so let me just look at this. Oh, so I added 30, that's why it should be negative, and then plus, because I switched the order of them. Okay, great. So now we have a area for him to walk in. So there's, this is the maximum X that he can walk to. This is the minimum X he can walk to. This is the maximum, sorry, the Z-axis. So that's the maximum Z. This is the minimum Z. Maximum X, minimum X. So we have like where he can walk to. So this is really good. So then now we need to actually do the code for him walking around. So picking a point and walking there is essentially what we need to do now. So you want to do on gizmo draw selected because like I said, this makes it really easy to see what he's going to do. If you don't do this, you can't see what he's going to do. You're just going to have to guess, and guesswork is just, you've been wasting a bunch of time doing that. So the next step is fixed update. So we're going to put an integer above this. We're setting an integer I equal to 600, right? And then every frame we're going to add 1 to this integer. So like this. And then we're seeing if I modulus 700 has a remainder of 0. I'm not going to explain how modulus works. You can just Google it. Basically, every 700 frames this will run. We're starting at 600 frames. So basically, if you enter the room, this will give there'll be a brief period of time before he starts walking to his first point. So then we need to get a point that's on the plane. So we've got these declared down here. We actually need to declare these outside of this so that we can use them. Like if we were going to use them in the fixed update. So we just need to declare them up here, and we'll just set them to 0. Okay, and then down here, we're not going to redeclare them. We're just going to use them again. So now we need to get a random point on the plane, right? Yeah, vector 3, random point on plane. Plane Jane. Okay, is new vector 3. And it's going to be a random range from the min Z, sorry, to the max Z. And then 0, because the y-axis is 0, because he's not going upwards or downwards, right? And then the same thing for, so, and this should be x and not z. So x is the first coordinate and z is the last coordinate. So like this. So this is getting a random spot on the plane that we determined the min and the max axes of the plane already. So it's just getting a random, this should be +1 technically, but the numbers are so high that it doesn't really matter. Technically, because the max is not inclusive, you should add 1 here. And then, so just -20. So we need to add the number or whatever. So what we could do instead of doing it like this is we could take these numbers out from here. And then we can just add this in the thing. So the max x is going to be -30. The min x is... Oh, it can still be negative the max x. Oops, should have fixed. Okay, let me just save this and go back and just make sure it still looks right. Okay, that way we don't have to do it all over the place. Like, add in -30 in the actual code here. It's just better like this. We could even separate this to make it look cleaner. So, okay, so I mean, we just separated it so it's a little bit more readable. So every 700 frames, it's going to get a random x and a random z value, and then it's going to create a point on the plane for us to go to. We're going to save this into a variable up here, and we'll just set it to vector3.0. Because that way we can draw a gizmo that will put a line between the two things. We can use this. Actually, let's just copy paste one of these. We'll just put it at the bottom here, and we'll make it white. So the from will be the current position, so transform.position. And the two, okay, so we don't, we actually want to put this into we're just going to rename this random point on plane to the destination because it makes more sense. It's where the character will be going to. Okay, so now if we run it, we should see that he just... Oh, we're actually going to draw a square at the destination point as well. So draw cube and just in 2. And then we need the size of it. So we'll just make it 30. Okay. Okay, so now when we run this, you should see him drawing yellow or white lines to where he's going to try to go every 700 frames. That cube is really big, so we're just going to have to change that. So look, he's picking random spots on the plane. You can turn on gizmos in your actual gameplay as well. So let me make the cube way smaller because that's obviously too big. So let's just do like 5. Okay, so and let's change this actually from a cube to a sphere. So when we get this destination point, the next thing we want to do is we want to check and make sure that it doesn't have any obstacles in the way of him walking there. So if he picks a spot that's directly on one of these rocks, it's already in the room, what will happen is he'll try to go into the rock and he'll just like be walking into the wall. We don't want that. So we want him to be able to only pick spots on the floor that don't have other obstacles that are in the way. So in order to do this, we can use something called an overlap sphere. So the reason I changed this to a sphere is because we're going to use this sphere as the location to check if there's anything there. So what we'll do is we'll destination clear is false, and then while not destination clear. So while the destination is not clear, we're going to get a new random spot, right? And then we're going to use physics.overlap sphere for the destination 15 because that's what's in our thing, and this returns a list of colliders. So we'll actually have to make a list of colliders for this, or sorry, an array of colliders. Hit objects. If hit objects. Wait, can we put a layer on this? I wonder if we can add a layer to this. Yeah, we can. So we only want to check for objects that are on the obstacles layer mask. So in your game, my obstacles that I have, these rocks, they're on the obstacles layer. So to create a layer, you can just press add layer and create a layer and then make sure you set it. So we only want to check for obstacles. We don't want to check for walls or anything like that because we set the boundary of the X and the Y to be inside of the wall. So he's never going to pick that anyway. But these are obstacles. So we just want to make sure he's not hitting any obstacles. So we just want to do layer mask name to layer obstacle. equal, make sure you spell it right or else it won't work. If hit objects equals 0, oh, sorry, hit objects dot count. Oh, it's a method group, shit, okay. So if it doesn't hit anything, then destination clear is true. And we also need to make a attempt limit for this. So number of attempts is equal to 0. So every time it tries this, it will number of attempts. It will increment this number of attempts that we're like the number of times that we're trying. And if the number of attempts gets to 100, then we're just gonna break out of the method. So basically the reason we're adding this is because in case you've done the code wrong, we don't want this to crash. So if it's in a while loop and it doesn't ever return true, then it'll be stuck and your entire Unity will freeze and you'll have to relaunch your thing. And Unity doesn't autosave, so you can see like we haven't saved it yet and there's like a little star at the top. Yeah, so it doesn't autosave, so if you haven't saved and you crash it, you won't be able to get it back. So let me just run this and let's see if it works. So we just want to make sure that he's not hitting any. So far so good. Okay, so this is clearly failed. He just picked a spot that has a rock. So the spot that he picked doesn't work. So let's go look at the code and figure out why it doesn't work. So if the count of the hit objects is 0, overlap sphere, the radius is 15. Oh, because we're not changing. So random X is not being changed. We have to change that every single time this runs. Okay, so it's a good thing we put this number of attempts because, again, we would have just tanked our game, and we've done this so many times that I know better than to do that. So if you do, yeah, you got to change the random numbers every time because it was just doing the same random number every single time, and that's why eventually it broke out of it, and it just did it instantly. So let's run it again and we'll see. And alternatively, if it doesn't find it, like if it still doesn't work, you could add a debug log to see when it actually breaks out of that or not. So you can log every single iteration of. So it doesn't look like the layer mask works properly. I don't know what is wrong with it. I read online and I guess you can put like 1 and then 2 less than signs to make it work with the number of the layer mask, but I'm just going to do it this way instead. So for each layer, or for each collider in the hit objects, if the collider dot layer transform.layer, oh my god, game object.layer is equal to layer mask get into layer obstacles. Okay, so I changed the way that I'm doing it. Instead of using a layer mask, which is like the better way of doing it, but it's just not working, we're just going through each of the colliders and checking the layer against the name of the layer. I think this is a better way to do it because I'm probably going to adjust my layers at some point. Maybe I'll change the numbers of them, so I don't want to be using a hard-coded number for the layer. That doesn't make any sense. So hopefully this will work. We'll find out in a second. Let me just change the fixed time to 50. That way it goes really, really fast. I just want to see right away whether it's working or not. So let's find out. Okay, so this is looking like it's working. It's not hit any of the obstacles yet, so I don't know what was wrong with the other one, but we're just going to leave it like this. It seems to be fine. It doesn't seem to have any performance issues either. It seems like it's going okay, so we're just going to change this back to 700, so it's going at the appropriate time. So this gets the destination. We might be better off to put this into its own separate method, so it's not cluttering your main thing. So if you cut all of this stuff, we could just make a void method up here. So just call it public void find spot. Oh my god, why does it do this? Jesus. Okay, and then we're just gonna get rid of this because it's not ever gonna hit 100 anymore because it shouldn't ever hit that. So this is just getting the destination, and we're saving the destination up here, so we can just leave this in this void method, and this doesn't actually have to be public. This can just be a void method. So every 700 frames we're gonna find a spot, and then so now we need to add a nav mesh agent to the enemy. So let's save this. So on our enemy container, we're going to add a component, which is going to be the nav mesh agent. And then for me, my speed needs to be really high. I think these numbers will work. Not 100% sure, but we'll find out. Turn off auto braking. Or just set the radius to like 15. So that's the same size as the sphere that's around my character right now. That's good for the this. And then the height could be a little bit taller because he's pretty tall. Let me just make it 10, whatever. Don't want to repath. We don't want to traverse off the mesh. Okay, so then we need to pass in this nav mesh to our code. So if we do serialize field, nav mesh, this doesn't need to be public. Neither of these need to be public. Oh, nav mesh agent, not nav mesh. Okay. So you're gonna want to make sure that the plane that your thing is on has a nav mesh surface. If you don't have a nav mesh surface, you have to. I think this is something you have to download from the internet. It's not included in Unity by default. Maybe in the new version it is. I don't know, but you just have to go and download it from the internet and put it into your project. It's a script that's available for free. Just Google it. There's a lot of videos on how to do it. Just watch a YouTube video. You'll be able to find out how to add the nav mesh surface. After you've added it, you just have to click bake. When you do, you'll get these blue lines. So I'll click bake again. Mine's already baked, so you don't have to. So anyway, yeah, so mine is already baked, so you don't have to worry about that. But when you click bake, you should get these blue lines. You don't have to worry about it baking on the edges as well, because for me, he's only going to be going to the maximum spots that we put on the thing anyway, so it doesn't really matter. So let's go ahead and so after we find a spot, we can set him to start going towards the destination. So to do that, you just do nma.setDestination and then destination, and that's it. So now when you run this, he should actually move towards the destination. No referencing. Oh, that didn't drag the nav mesh agent. So inside of your cow enemy, you just gotta drag the nav mesh agent into the slot where you because we made this a variable, so you have to drag the nav mesh agent into the slot and it should work. Okay, so it looks like this is way too fast. Okay, so just to save a bunch of time with fucking with the numbers, I'm just gonna go to the one that I already completed and find out how fast he's going. So hang on, prefabs. Actually it's in the script, isn't it? Yeah, that's right. Cool. Okay, so now we're gonna add a start method here. So we'll just add start. And we're just going to set the numbers to this. So the speed that he's going right now is obviously it's way too fast. Okay. So a good ratio is 50 to 200 to 1,000 or sorry, 10,000. I mess with these numbers a lot before coming to them. So you don't need to worry. Like I just guessed these, but it's clearly wrong. You could see him like sliding around everywhere. Another thing that you need to do is if he reaches the destination, we want him to stop walking. So we need to attach the animator to this script as well. So we need to do serialize field. Oops, shit. Animator. We'll just call this A, why not? So the speed at which he's walking might need to be a little bit faster. We could either change that by going into the animator here and just multiplying his walk speed by like 2 or something. But when he starts chasing your character, you're going to want it to update and be faster because he's going to start running way, way faster when he's chasing your character because he's just walking around initially and then he's going to be chasing you. So when he's chasing you, he's going to have to move his feet faster. So if he gets to the destination, we want him to stop moving. So I've already made a script for this. I'm just going to copy paste it and then I'll go over what it is after I copy paste it. Okay, so this script is just directly copied off the internet, so you can probably find this somewhere online. So if the remaining distance is 0 and the path is complete and the distance is not equal to math.infinity, then we're gonna get the animator. So we already got the animator, so we should actually just put A here. And we're going to set the speed to 0. So this will stop him from doing the walking animation. So when he reaches his destination, he shouldn't just keep walking forever. He should stop and stop moving his feet and then carry on when he gets a new spot to go to. So this will set his... Okay, so this sets his position to himself as well. Also, we should put his rigid body Oh, we'll just leave it like this. So this gets the rigid body and it sets the constraints to freeze everything. Basically what this will do is when he's stopped, if you have a rigid body attached to him, he'll slide around a little bit. So if he like stops at a location and he has a rigid body added and you haven't frozen the position, he can slide a little bit. But we also want to turn this off when he starts moving again, because if you hit him, you want him to move backwards, or if he runs into you, you want him to move backwards. This will prevent him from getting on top of you. So we're just gonna put this into here right before this, and we're just gonna freeze the Y position. So only the Y position, we don't need to freeze anything else. Yeah, exactly. So that's perfect. So let's see what this does now. So he won't resume walking, so that's another problem. Oh, we didn't assign the animator. So inside of this, we need to take the animator and assign it. Parameter speed does not exist. Okay, so inside of the animator, you have to add a float for the speed. And just set it to 2. And then inside of walking, change the speed back to 1 and then add a parameter as a multiplier and choose speed. So because in the code, we're setting this speed parameter to 0 to stop him from walking. The next thing we need to do is actually when he finds a spot, we need to set the speed back to 2 so that he's walking at the same speed that he was. So he'll stop walking when he reaches the destination, but then when he finds another spot, he'll start walking again. So, and this might even be better if we start it with him not walking, because he's going to be walking on the spot for 100 frames, it looks like, before he starts moving. Okay, so we're just going to put this variable at the top here, and we're just going to change this to else if. We don't want these both to run on the same frame. We want them to be separate. So if this happens, then it'll do this. Else, if this happens, it will stop it. This sets it to stop. We want this to be true. So the reason it's not working is because we stopped the nav mesh agent, and we want it to actually start again when he finds a spot. So we'll find a spot and then we'll turn off. We don't want him to be stopped anymore, so we want him to keep going. Alright, so now you see he's gonna walk endlessly around the room. He's just patrolling. This is what an enemy should kind of do. And he won't like pick any positions where there's obstacles. This is what an enemy should do. So you won't find something like this in any of the other tutorials with an actual enemy that's going to be in a game. You'll find it with like cylinders and stuff like that, and their videos are kind of like, you can't apply it to an actual game. So right now I can walk through him as well. So we're going to have to fix that. And we're going to have to make him start chasing. So we're going to have to add a bunch of stuff. So in the container for your enemy, just go ahead and add a box collider. So this way you can't walk through the enemy. And then if you click the edit for it, it looks like it starts really, really small. So we just want this to be like 5 or 15 for the center. Maybe 15Y, maybe 100Y. Jesus. 50, the ground. I'm gonna make it 50 tall. No, 70 tall. Yeah, 70 is good, and then 35. And then we'll make it like 50, 40x, 40Z. That's too big, so let's just make it 25. Okay, so the box collider will make it so like if you walk into the enemy, it will kind of push you away. I'm not going to show you how to damage your player or whatever, because you probably don't have, like, if you're following this video, you don't have the same player that I have. You'll have your own player scripts for taking damage and stuff like that. So I'm just going to add a pre-made method to damage me when I hit me. So if on collision, if the collision dot name, that's right, collider dot name is equal to stick man wizard. I think I can do enemy interaction dot clear hit. I'm not sure if this is a static method. The thing that hits you will be this. Cool. So I'm not going to go through how you can damage your own player, or because like in your game you're going to have a different player than I have. So this is how you'll handle that. So when he collides with your player, if the collider is your player's name, you could have a method that damages your player. I can briefly show you this if you want to see it. Basically, it pauses the movement. This is a static variable in a static class that I have, and then it reverses the rotation. You can copy this code if you want to, I don't care. So, and then I change my color. This is using a shader, so if you're watching this, you probably won't know how to do this stuff, but you can copy my code if you want. You'll have to match the set color with the name of the color inside of a shader that you're using, or you could just set dot color to be the same colors as I'm using. This last field is a transparency, so it kind of makes him flash a little bit when he takes damage. I'll show you what it looks like when I take damage. Okay, so I'm just gonna copy this whole method. In my other script for my enemy, I'm using an abstract class to do there's a bunch of methods like hitting the player. I'm not going to rewrite that every single time I do an enemy, right? So I just reuse this based on my enemy script, and then I can inherit this class from my other class. I'm not going to show you how to do that because it's too complicated. If you're watching this video, you wouldn't need this video if you already knew how to do that. So I'm just going to quickly copy some of the methods from here. Again, this is just for damaging the player, so you can skip this if you want. You're not going to be damaging your player probably, so it doesn't really matter. You're not going to actually have a player to damage. This is just more about the enemy script. So okay, so if the collider is a stickman wizard, we'll stop nav meshing. So this is the thing that we're attached to. So in my game, so what I'm doing right here is when I hit the player, it will stop the nav mesh agent temporarily because I'm pushing the enemy backwards. You can copy this if you want to. This is really helpful. If you don't push the enemy backwards, character controllers and box colliders have a problem where one will go on top of the other. You'll walk right on top. You saw that when I was just playing in the actual run through. Your character will go directly on top of the enemy. And to prevent this, if you hit the enemy, you can get pushed back from the enemy, and it looks more natural anyway. I'll show you this running. Yeah, and then we need player hit. So we can call this from that other class that we were using. Enemy interaction. Player hit. And then this is just my death script, so you don't have to copy this, but and this draws the player's heart, so that you don't need that. But this pushes the character back. So this stops the nav mesh agent, and then this pushes the character back. This is really good, and then it waits 0.4 seconds, and it turns the nav mesh agent back on. Really, really useful. I'll show you the difference, but okay. So something to notice as well is when I walked into the player or the object, this didn't do damage to my player. It only does it when he walks into me, but not when I walk into him. So in my other script for my enemy, I have it where the player, if he walks into an object of the type enemy based on the inheritance, it will do the same code or whatever. So on controller collect, so this script, enemy interaction, is attached to my player script. So if I walk into any enemy, then it will do the same thing that I just added to my player. Now my other script inherits from enemy, so it technically is a type enemy. I'm not going to do that for the tutorial enemy script because it's going to take too much time. This video is probably already going to be over an hour, but I just thought I'd show the full process of making an enemy. So this is how long it could take for an enemy, and you could reuse the script as well, but I'm not going to make this inherit from enemy, otherwise you wouldn't see a lot of the code, because I've just baked it into an abstract class, and I just reuse the abstract class every single time for every enemy I make. I just reuse a bunch of the abstract stuff. This stuff can all be in the abstract class. It doesn't have to be in, because you're going to want to find this stuff on every single enemy, not just this one. So you could put this inside of the enemy script and then inherit from it, and then all of your enemies will have these by default. So if you take this and you just dump it in the enemy thing, and then all of your enemies you can inherit from enemy instead of mono behavior, and then enemy will inherit from mono behavior, so it will become a mono behavior based on inheritance. But again, like I said, that's probably too complicated for what I'm showing you in this video, and I'm not going to bother showing you that. So that's how you can damage your player. So the next thing we need to do is have a Boolean value for whether he's chasing. So chasing is going to be false by default. So every single frame, if he sees the player, he needs to start chasing, right? So you want to set that up here. So we're going to steal this one. Let's just steal this whole thing, and we'll just put it up here for now. So check if the player is in front of you. So we don't need a gizmo, and we don't need to draw array, so get rid of that. So if physics.raycast direction, oh, sorry, the origin will be the cow, and then the direction will be where it's getting cast to. So if this, we want to output the cast hit R H, and then we can put out RH. Okay, so we're going to cast array in front of the like in front of the thing that we're attached to, which is the enemy, in the direction, which is the same as what we're doing in the gizmos. So we're doing this down here. So this green line that's in front of him, this is the same thing that we're doing in the gizmos, right? So if this hits him, then we want to set him to be chasing. Okay, so if chasing, else if. Okay, and so when we set chasing to true, we need to change these values for the speed because we want him to be chasing significantly faster than when he's just idle walking. So when we set chasing to true, we want to just change all of his speeds for his NavMesh agent to be way faster. I'm just going to steal the numbers from my other code. So these are the numbers that I used. So let's just do that. So we found the Stickman Wizard, so we start chasing, so it's going to go way faster. And then we want to, every 30 frames, instead of 700 frames, every 30 frames, we're going to update the destination to be the player. So, okay, so I have a static variable for my player's location, but you're not going to have that, so I'm just going to do it this way so that you can see how you could do it if you're following along still. So we'll do game object. Actually, just transform is fine. Player position. And then you can just set the destination to be the player position. Dot. And then dot position. So then back in your cow script or whatever, you can drag the player that you're chasing into there. If you don't have a player, you could just add a circle to the game or like a sphere or some type of game object, and you can set that as the position, and then you could drag it around and watch the cow chase him if you want to, or watch whatever enemy that you're coding chase him. So then we also want to make sure that we're setting this to no, because we're not going to stop, so we don't have to set that. So we update the position. The speed needs to be changed as well. So when we have a target, we're just going to change the speed to 5 because he's going, hang on. So this is 150 and he's going, what, 50 by default, I think? So it's 3 times faster. So we want it to be 6. So it's 3 times faster than the animator as well. So now when he sees our player, he should start chasing him like a maniac. So if we go in front of him. Okay. Let's change this from 0 to 10, so it's off the ground a little bit, so it's not going directly on the ground. I think I have that down here as well. No, I don't have that. Oh, when I draw the ray, I do, though. Yeah, so the origin should have 10 in the y-axis as well. So it can't just be transformed.position. It needs to be, so this is the origin of where the ray's coming from, and we don't want it to be on 0 on the y-axis. We want it to be above the ground. So we need to put new vector3 transform.position.x 10, so it's off the ground, or 15, it doesn't matter. It depends on your game how high like your players are or whatever off the ground. Okay, and the direction should be 0 because we want it to be flat. So if the origin y is 10 and this is 0, it will be a flat line. If it's 10 more, then it will go like upwards on an angle. So anyway, let's run this again and see if our cow can see our player now. Yeah, so you can see now he chases the player around like a crazy cow. Okay, so he's getting caught in this 700 one or whatever, because this is returning false because it's not modulus 30 and it's hitting this. So else if this, but also we need to put and not chasing, and not chasing. So we don't want these to run when he's chasing. We only want the set destination to be running, so he's like just chasing after or whatever. That should be the only thing happening, and there shouldn't be this is no longer needed as well. So if we only want to be checking this if he's not already chasing. If he started chasing, then you don't need to check this anymore. If you press Control K and then F on your keyboard, it formats the selection. This will like fix your code up. If you ever have like spacing problems or it doesn't look right in the code, you could just highlight this section and press Control K, Control F. So this will fix the problem. So he'll continue chasing indefinitely. Okay. Man, he's so big. Let's go really close to, oh shit, okay. So now you can see he's chasing. There's still this gizmo here, but it doesn't matter. It's not doing anything. It's just a drawing. And like I said, in the real game, like when you're actually playing, this is what you see. You don't actually see the gizmos. They're just used to determine what's actually happening in the screen. So let's turn this off and let's get out of this. So the next thing we need to do is add his attack. So he should be attacking like once every like a random amount of time. It shouldn't just be actually always. He should just randomly be attacking. So let's go and add that. So once he starts chasing, we're going to need to start a coroutine called attacking forever. So we'll just set that up here. So my enumerator attack forever. And then let me just steal these wait per second thing. I never remember yield return wait for 2 seconds or whatever. So, oh my god. Random range 5 to 15. For now. So what we're doing is we're going to wait a random time between 5 and 15 seconds, and then we're going to do an attack. Okay, so by putting it random, he won't just keep attacking in the same exact interval because that's boring. He'll attack specifically when, like, he'll attack at a random time between these numbers that you're creating or whatever, right? So the next thing we need to do is we need to add the animation for him attacking. So back in your animator, you need to make a new state for this. And I think that for me, it's not a blend tree this time. It's just the state. So just put attack, and then we'll do. If you right-click walking, you can make a transition and make a transition back. So between walking and attack, there should be no exit time, but also there should be no transition duration. We want this to be exactly just the full duration of it. Otherwise, because we're going to use an event to trigger the visual effect that happens. So when he's done attacking, this does have an exit time, but you should make the exit time 1 second and change the transition duration to 0. That way the full animation will play. Then we need a trigger. So at the top left here, if you click plus, you can add a trigger and just call this attack. This is what's going to actually cause this to happen. So in the conditions, if you hit plus here, you can click attack. So when this trigger happens, it will do an attack. And then if there's no return parameter or anything like that, as long as there's an exit time, it will go back to whatever it is pointing to. So the first thing you've added, that if there's an exit time, it will go directly back to where it came from. So you only have to set this. So when we trigger this attack, he'll do this animation. So we need to drag the animation from this into the thing. So we'll put this here. And the other thing we need to do is we need to, so if you didn't copy this out of the model, you have to copy this out of the model because we're going to add an event to it. So if you double click on the animation, you can click somewhere in the animation. I think here is where he has the gun loaded and he shoots. So you can add an event. So you click this little button here, it adds an event. And we're just going to put the event to attack. And then we need to pick the script. So mine's called tutorial something. Tutorial enemy script. And you don't actually have to put the brackets here. So just attack like this. So what this will do is at this point of the animation, this function inside of this script will get called. So if we put an attack function here, it has to be public, by the way. It has to be returning a void. Well, actually, it can return other things if you want to mess with the settings. You can have inputs as well if you want to. So this will happen when this event in the animation happens. This is the best way to handle attack animations or visual effects happening within an attack. So this will happen exactly when this line is. And at the end, you could make it stop the animation if you have like any leftover particles or anything like that. I don't think we have anything like that, so we're not going to do this. But if you don't set the exit time to exactly 1 second, this last frame will never trigger and your event won't play essentially. So that's why you need to change it to 1 and not 0.75. I don't know why it does that by default, but I haven't really found that very useful for me. So in my other cow that I've already made, hopefully I can find one here. Hang on. Cow enemy container. I have these two particle systems, and I'm just going to copy them. I'm not showing you how to make particle systems, and this is going to take too long. This is already really, really long. So we just want to drop this here, and then we'll just hit play on them again and see where they're coming from. So we need to reset them to 0. Probably just the position. Oh, okay, I don't think I changed anything else. So, okay, so if we run this now, what happens? Here we go. Okay, it's the load gun one. What does that do? Oh, there it is, okay. So just put that down a little bit. Okay, so we want this kind of on his left side, because his hammer is on his left side when he's actually going. And then the gun attack can come from the actual... Like, it's fine the way that it is. It should just go up a little bit. Now, you don't have these, but so you'll need to create a particle system for the attack if you want to do that. Like I said, I'm not showing people how to make a particle system in this, so if you want to learn how to make a particle system, just watch some of my other videos. I've already covered that like numerous times. And this is using custom drawings, so you probably won't have these drawings available to you. So anyway, so now we have these two, so we need to put them into our script. So at the very top here, we'll just make 2 more fields for particle systems. Sorry, attack load, and then this one will be attack. Perfect. And then back here, we can take these and dump them into the... Oh, you can't put attack. You gotta do attack PS or something. Because we've created a method called attack, so you're not allowed to name them the same thing. Okay, so the load gun one can go in the load one, and then the attack can go in the attack one. So then back in the animation, we need to double click this again. So probably right about here is when he actually loads it. And then actually it's probably like this, I would imagine. Yeah, so then we need another event. So this one's called load gun. And it will also be in the same script, obviously. Oops, crap. Okay, so essentially at this position of the animation, he'll load his gun, doing the first particle system, which is like loading his hammer gun or whatever. And then this is where it will actually shoot the particle system. So let's see that. So this is attack, and then this is load gun. So PS load gun. And then in this one, we'll do attack PS. Okay, so in this attack forever, it will wait this period of time, and then we'll take the animator and we'll set the trigger attack. And then we need another IEnumerator to reset the trigger. Actually, we don't need an IEnumerator. We can just do public void reset trigger, and then we'll just do the same thing, but instead of set, we'll do reset. And then you can invoke this reset trigger after 0.5 milliseconds, or sorry, 0.5 seconds, not milliseconds, and you've got to put a comma there. So if you don't reset the trigger will stay set, and we'll just keep playing the attack animation over and over and over again. Or if you don't have it set to looping, it will just play it once, and then your cow will stop walking or whatever, right? So invoke, this is the same as just calling this method, but it does it after this period of time. So you could also accomplish this by using an IEnumerator the same way and just yield return for 0.5 seconds or however long you want to, but it needs to be less than the duration of the animation. If it's not, he could either do multiple animations in the time frame, or he won't go back to walking, and you want him to go back to walking right away, like as soon as possible. As soon as he's done attacking, you want him to go back to walking. So now if we've done this right, so the next thing we need to do is, after you've invoked this, you just want to do this again. So start coroutine attack forever. And this will wait another 5 to 15 seconds, do the attack, and then do the same thing again. If you had multiple attacks, you could add, so when you have set trigger, you could add a random range between 1 and the number of... So let's say we had 2 attacks, right? The first one's named attack 1 and the second one's named attack 2. If you just add a random range between 1 and 3, this is not inclusive, so it would only go between 1 and 2, right? And then it will set that trigger, and it could be random. Now, we're not doing multiple attacks today because, like I said, we don't have time for that. So, should I just click play? We're just going to use this one attack, but you could random between 1 and 2 and just name your triggers attack 1, attack 2, attack 3, etc. And you could just random a number after this and add it to the string. And then you have to reset the trigger, and then you do it again. So then the last thing we have to do, is actually call this coroutine. So when we set this stuff, we need to start this coroutine. So we'll just start coroutine. Let me just start coroutine attack forever. So now when you run this, every 5 to 15 seconds, or 14 seconds, because the maximum is not inclusive, he should be shooting only when he's chasing though. So when he's chasing you, every 5 to 15 seconds, he should do his attack. So I also have audio for this in my other script. I'm not going to show you how to do audio, okay? So just when he does the attack, you could add audio to it. There's hundreds of videos on how to add audio. You have to add, I have an audio manager added, so that's how I added audio, but I'm not going to be showing you. I could add the audio anyway, so you can see it, but there's a Brackeys video on how to do it. You can just add that. So here I have... There's 2 things. There's this, and then this. Okay, so then the next thing is, this won't damage my player yet. So we want this attack to damage the player. I've written a script that does this. So, it will damage the player because I already added the script. So I've written a script to do this. So let me just open the script, and you can copy it if you want to. Let me just see if I have it open. So here's the script. So you attach this to your object with the particle system, and then you can drag the particle system into this portion of it. Let me just scroll down for you. So you would obviously change the collider name to be whatever your collider is. You won't have player.invincible, so you can just remove this portion. And then this is what where it collided. So this is useful because I knock my character backwards, so it needs to be backwards from where the point that it collided. This is just the same code that I used to damage my player, so when it collides with my player, it damages him. So you can copy this if you want to. I don't think you can use the bottom portion of this, but like I said, there's lots of videos on how to do that out there. So now if I get hit by the gun, it should make noise, and if I get hit by the gun, it should damage my player. So let's see. Okay, so I'm just purposely getting hit by it. So you saw that hit the player and it kind of knocked me backwards. And if the cow walks into me, he kind of gets knocked backwards. I probably need to change the force to be a little bit less when the cow gets hit by him. Like the cow gets knocked backward too far. So basically what we've set up here is the cow will walk around and look for you. This is how like a lot of enemies are in a lot of games where the enemy will kind of patrol and look around for you. And then when he finds you, he'll start chasing you and shooting you with the particle system. Like, this is reusable in pretty much all of the enemies in your game. And like I said, if you create an abstract class for it, you can reuse enemies, like the script. You could just reuse it and have like some of the methods separate. I created a different video on abstract classes, so if you go through my videos, you can find that, and you can learn how to use an abstract class if you want to. It's really, like, it's more complicated than this video is. This video is just like the absolute basics on how to make a good enemy that doesn't like fucking suck, right? So this is a really good start for an enemy. So he finds you, he chases you, he can shoot you with the particle system. That's pretty much all you need for an enemy. This is how I set up my bosses. This is how I set up this enemy. You might make chase music as well if you wanted to. Like when he's chasing you right now, he could have like music playing and stuff like that. But this is how I've pretty much set up all my enemies so far, and it's been really good. Having these gizmos especially is just so handy for like setting this up. So if you guys learned anything, make sure you like the video, because this took me a long time and I already wrote this code. So I'm just redoing this literally just for your purposes, and it's probably only gonna be like 10 or 15 people that watch this video. So make sure you like and subscribe if you liked my video, and hopefully I'll see you in the next one.